Hello dear students, welcome to YourPedia. You all know that TS GENCO is about to release one very good notification for its assistant engineer jobs. 350 posts are there. In that, majority of the posts, 60 to 70% of the posts will be for electrical. We, YourPedia, located at Hyderabad in Surilo complex at Abbots. We are offering one online, very good online course, an effective result oriented course at an affordable rate. I can say at the cheap rate. The cost of the module is very less with a very good test series. So in this video, I am going to discuss some previous GENCO questions that were asked. Not only GENCO, I collected questions from GENCO, Transco of different exams that were held in Telangana state. Some 20 questions I collected. So this kind of videos you will be getting regularly. You will be getting regularly in the YouTube. Okay, yeah. Today I am going to take some 20 questions from power systems. See here, in these questions in YouTube especially, I am going to teach you concept, how to remember the formula easily. Suppose in examination we'll forget, for sure we'll forget in examination. Why? Because there are many formulas. If you forget how to recollect that formula, if you can recollect the formula if you know the concept, right? There are some theory questions also. Theory questions are very easy, but mostly I'm going to concentrate here on, means my explanation will be mostly on, I can say, problematic questions. There are theory questions also. That explanation of theory questions is very easy, but the one which is going to decide your job will be theory question only in exams like GENCO. So I suggest you to go through the theory concepts like generation concept in power systems and power system protection concept. Okay, from generation concept, definitely at least 2 questions will be asked theory based. Okay, let's enter into the problems. Regularly you will be getting 20 previous questions of various various competitive examinations in that were conducted in Telangana. Okay, yeah. And one more thing, almost if you see the previous papers, the questions are repetitive. The question which was asked in NPDCL in I can say 2014, the same question got repeated in AEE exam of power system, in power system subject, I can say. So if you are able to solve all previous engineering services questions, objective questions, and all previous gate 1 mark questions, and all previous these competitive examination questions, believe me, means not just mugging. If you are able to solve, if you know the concept of all these things, believe me, definitely you can get the job. So this is the simple fundamental, and don't try to do the research on the concepts at this point of time. This is my suggestion. Prepare in examination orientation way. See, YourPedia is a famous platform for competitive examinations like HPCL, IOCL. See, IOCL is recruiting through GATE. HPCL is one of the examination which is conducted in India, and one more exam, CGPDTF, for central government examinations and other state government examinations. If you take Punjab JE, Haryana JE or SC, whatever it is, whatever may be the competitive examination, we are the market leaders in this online platforms, right? So I suggest you join your hands with YourPedia to escalate your preparation, to accelerate your preparation, right? Let's enter into the concepts. The first question is, a transmission line has 1 per unit impedance on a base of 11 kV, 100 MVA. On a base of 55 kV, will have a per unit impedance of, this fellow did not mention transformer is either star or delta. By default we will take it as star. And one more thing, either you take star or delta, per unit values are always per phase values. Per unit quantities are always per phase. Okay, so you have to use per phase quantities if you want to find the per unit. But if I am using per phase or line, both are giving same answer, then it will be easy for me to use line quantities and 3-phase power. Let me write here the concept. Yeah, observe here carefully the solution of the first question. See, Z per unit is equal to Z in ohms by Z base in ohms. Any per unit quantity is equal to actual quantity by base quantity, and per unit quantity is not going to have any units. So this is simple formula, you all know, right? Now Z base. Sir, how to select Z base? First of all, he given what he given? He given 1 per unit as his old per unit value, 1 per unit, that is equal to Z in ohms by Z base. Z in ohms by Z base in ohms. Now, if I get Z in ohms, I can get, if I get Z in ohms, I can get Z per unit new. If I have ohmic value for any new base, that is easy for me to calculate. There is one formula also. In the last I'll tell you the formula in the discussion of this question. In the last I'll discuss that formula. But if you forget the formula, Z in ohms is equal to 1 per unit into Z base. What is Z base? Z base is equal to, Z base in ohms is equal to V base whole square per phase by S per phase, single phase MVA. If this is in kV, voltage is in kV, K square will be 10 to the power of 6. If this is in MVA, that 10 to the power of 6, this 10 to the power of 6 will get cancelled. Means if you are taking voltage in kV, S will be in MVA. Therefore, you need not to put the 10 cube, 10 to the power of 6 and all that. Directly you can calculate. That is the point. So this is in kV. Then definitely this must be in MVA. But if it is a star connection, V line to line is equal to root 3 times of V phase, then what I do is I do multiply with 3 this numerator V base square per phase by 3 into S base per phase, S base single phase. Observe it, ma. S base single phase, right? So observe it. Now I multiplied with 3, divided with 3. See, I am explaining the concept. Getting the solution of that question is 30 seconds matter. Okay, but see why I am telling you. Suppose if that fellow gives delta by star, star by delta connections and all, then you will be caught. No one knows. See, I can say most of the people don't know that per phase quantities, per unit quantities must be calculated only per phase only. They simply make the formula V line to line whole square by S 3 phase. That is valid only for star connection. If it is delta connection, you have to take this S base single phase only here, the denominator. Why? Because for delta connection, line voltage and phase voltage both are equal, right? Now observe here, all of you. So Z base in ohms is equal to, I'll set this 3 inside, then I can write it as root 3 times of V base per phase. Root 3 times of V base per phase is equal to V line to line whole square by S base 3 phase. Right? So this is valid only for star connection. If it is delta connection, this will be phase voltage, but for delta connection, phase voltage, line voltage both are same. This should be single phase. Otherwise, you will get the wrong answer. That wrong answer will be the first option in the options. Okay? Yeah. Now observe here. So Z base old Z base is what? 11 square by, I forgot the data. Let's come back. 11 square by 100. Yes. And new is 55. New is 55. Just voltage is changed. New is 55, 100 MVA. Now Z in ohms is equal to 1 into 11 square by 100. Now Z per unit new is equal to Z in ohms into S base by V base square. Right? These are the new bases. See, if you multiply per unit value with V square by S base, you are going to get ohmic value. If you are multiplying ohmic value with S base by V base square, then you are going to get per unit value. So how much this is? Come back here. How much this is? Z per unit new is equal to Z in ohms. How much I got? 11 square by 100 into S base new is 100 only, but this V base is 55 square. 55 it is. This gone. Then you are left with how much it is, ma? 1 by 5 whole square, right? So 11 by 55 whole square. 11 5 it is 1 by 5 whole square. This is 1 by 25. 1 by 25. I can write it as 100, see, simplification is also important. Yeah, so I can write it as into 100 divided by 100. So 25 force, it is 0.04 per unit is the answer. 0.04 per unit is the answer. I will give the formula also. But why I taken this much discussion? If it is star or not mentioned anything, this is correct. But if it is delta, you have to carefully think that this is the formula. Per unit quantities are always per phase quantities. Just people will learn the formula in line voltage and three phase power, but they won't learn with per phase and this per phase power, phase voltage and per phase power. Okay, yeah. What is the formula? See, if you remember the formula, that is easy, but that formula, which formula to what it is applicable, you have to understand, right? Yeah, so Z per unit new is equal to Z per unit old into, yeah, I can say like S base new by S base old into V base old whole square by V base new square. Now Z per unit old is given 1, S base new is 100, S base old is also 100, V base old is 11 square, this is 55 square. So that is equal to this gone 0.04 per unit, right? But again I am saying, or otherwise I'll write in the form of note. See, this copy of my writing and questions you can download from our website. So all these things you can download from our website. See, one of the very important note point is, see, per unit quantities are per phase quantities always, per phase quantities always, per unit quantities are always per phase quantities. Second thing, Z per unit is equal to Z in ohm into, yeah, S base by V base per phase square. This is single phase. That is equal to Z in ohms into S base 3 phase by V base line to line square for star connection. For delta connection there is no way. Definitely I have to take always. For delta connection, let me take a new page and write there. Yes, see, for delta connection, yes, Z per unit is equal to Z in per unit is equal to Z in ohms into S base per phase by V base per phase whole square. But this V base, fortunately or unfortunately, is equal to, per phase is equal to line voltage. These are equal. Means either you take line voltage or phase voltage for delta connection, both are same. Line voltage is equal to phase voltage, right? So let's go to the next question. See, this question is very simple. A 50 Hz 4-pole turbo alternator rated at 20 MVA 13.2 kV has an inertia constant H is equal to 4. Inertia constant H is equal to 4 kilowatt second per kVA. The kinetic energy stored in the rotor at a synchronous speed is H is equal to 4 given. See, what is H? Inertia constant H is equal to kinetic energy in the rotor body, kinetic energy stored in the rotor body, by rating of the machine, generator. H is equal to 4. I need kinetic energy by how much is the rating he given? Rating is 20. So from this one, if you calculate, so K is equal to 4 into 20. But here I have 80 megajoules and 80 kilojoules. See, he is very clever. Okay, you get the 80, but it is 80 kilo or 80 mega. Let's understand. So that's why units are very important. When you are solving a problem, units are very important. So he given H is equal to, H is what? 4 kilowatt second per kVA. He given 4 kilowatt second per kVA. Now he given G or rating of the machine in MVA, So G is equal to 20 MVA. So 20 into 10 cube kVA I can write. 20 into 10 cube kVA. Now kinetic energy is equal to H into G. 4 is in kilowatt second per kVA. Simply I can write it as kilowatt. This k will get cancelled. Watt second per VA. 4 is watt second per VA, and this is into 20 MVA. 20 MVA. Therefore, it is 80 megajoules. It is how much? 80 megajoules. You don't have to think much about it. This is of kilowatt. K got cancelled. 4 kilowatt. 4 into 10 cube watt second. Watt seconds are nothing but joules. 4 joules per volt ampere. 4 joules per volt ampere. That kilo got cancelled. This line is not required. In fact, that line is not required. See, be careful when you are solving the problem. Units are very important. Let's go to the next question. Yeah, the inertia constant of two group of machines which do not swinging together are M1 and M2. The equivalent inertia constant of the system is. This is direct question. So there is no much explanation about it. If two machines are swinging together, then their M equivalent is equal to M1 plus M2. If not swinging together, see, if N machines are swinging together, then M equivalent is equal to M1 plus M2 and so on Mn, right? If N machines are not swinging together, if N machines are not swinging together, then M equivalent, in fact 1 by M equivalent is equal to 1 by M1 plus 1 by M2 and so on 1 by Mn. Here question must be raised, that is, what does it mean by swinging together? If both the machines are having same load angle delta, that is called as swinging together. Both the machines must have same load angle delta, swinging together. Okay. So in the next examination, the question may be asked, if two machines are swinging together, both the machines have, he will give some 4 options. You have to select the correct option. See, that's why having concept is very important. There is a derivation for it which is not required for our competitive examination. Okay. So as he given two machines, 1 by M equivalent is equal to 1 by M1 plus 1 by M2, then M equivalent is equal to M1 M2 by M1 plus M2. Simply to remember parallel combination of resistances formula. If two machines are not swinging together, parallel combination of resistance formula is M equivalent. If two machines are swinging together, the series combination of resistance formula, that is the summation of all the values, will be the equivalent resistance, right? Next, this is a good question from load flows. Yeah, he's saying that a 12 bus power system has, this is bus, the 12 bus power system has 3 voltage controlled buses. Yeah, here many people will think, sir, what is a voltage controlled bus? Sir, we know PV bus, we know PQ bus, we know slack bus. What is voltage controlled bus? Voltage controlled bus is also one of the PV bus with P equal to 0. Voltage controlled buses will come under PV buses, right? The dimensions of the Jacobian matrix will be, so first of all, number of buses is equal to 12 and number of PV buses PV buses is equal to M is equal to how many? He given voltage controlled buses 3. Voltage controlled bus is nothing but PV bus with the P is equal to 0. Right? Now Jacobian matrix size is 2n minus m minus 2 by 2n minus m minus 2. So that is equal to, Jacobian size is 2 into 12 minus 3 minus 2. How much it is? 24 minus 6, 18 it is. 12 2s are 24. 24 minus 6. 24 minus 6 will be 18. So the answer will be 18 by 18. Answer is 18 by 18. Look at the options. Options are not there. 2n minus m minus 2 by 2n minus m minus 2. How much it is? Just let me calculate. 2 into 12 is equal to 24. 2n minus m is 3. How much it is? 24 minus 3 is 21. 21 minus 2 is 19, please, not 18. My calculation went wrong. It is 19. Yes, it is not 6, it is 5. 3 minus 2 is 5. Okay. So 24. See, in examination, we can commit this kind of silly mistakes. We may lose the marks. That's why, see, 24 minus 5, it is 19. Answer is 19 by 19. 19 by 19. Choice is C. Let's go to the next question. For a fault at the terminals of a synchronous generator, the fault current is maximum for a, except at the generator terminals, everywhere 3-phase fault will give maximum current, but on the generator terminals, I repeat, on the generator terminals, line to ground fault or single line to ground fault or one phase fault will give more fault current. Single line to ground fault, line to ground fault. At anywhere except at the generator terminals, at anywhere you take, 3-phase fault is going to give maximum fault current. Please do remember these 2 points. These are the outcomes of analysis. Once you do fault analysis after taking positive reactance, positive sequence reactance, negative sequence reactance and zero sequence reactance, if you do, definitely you are going to get the same, right? So next question. If all the sequence voltages at the fault point in a power system network are equal, then the fault is, all the sequence voltages are equal for line to ground fault, LLG fault. In LL fault, there is no zero sequence voltage. Zero sequence network itself not going to exist. Why? Because that fault is not associated with the ground. In LG fault, VA1 plus VA2 plus VA0 is equal to 0, or VF fault voltage. Is LLG fault, line to ground fault, line to ground fault is going to have all 3 sequence voltages equal, that is VA1 is equal to VA2 equal to VA0. It is double line to ground fault, so VA1 is equal to VA2 is equal to VA0 for LLG fault. Yes or not? Yes. So that is the option. Let's go to the next question, that is, which material is used in controlling the chain reaction in a nuclear reactor? Thorium, heavy water, boron, beryllium. Boron and cadmium is also used. Cadmium, okay. So as cadmium is not there, we are taking for boron. Boron is the material. The theory questions, if you know the answer, you can directly tick. Sometimes he may not give boron if he is giving cadmium. Cadmium is the answer. He may give both also, right? Let's go to the next question. The transient stability of the power system can be effectively improved by, transient stability. We have 2 types of stabilities. One is steady state stability and second one is transient stability. Steady state stability is also called as small disturbance stability study, right? And transient stability is also called as large disturbance stability study, right? So transient stability can be improved by, excitation control is for improving steady state stability. This is to improve steady state stability. Phase shifting transformer, no. Increasing the turbine valve opening, no. So single pole switching of the circuit breakers is going to improve transient stability. How? I will tell you. There are 2 types of circuit breakers, single pole and 3 pole. 3 pole means if you operate on one phase, all three phases will get operated. That is called as three pole. Means with a single switch, all three phases will be either connected or disconnected. Now, what is my acceleration power PA? Acceleration power PA is equal to steam input minus electric power output. So PA is equal to PS minus of this electric power output. I write it as electric power output of phase R, phase Y, phase Y plus phase B I can write. Now, if you are using three pole circuit breaker, means fault occurred on phase R. Now you are operating this one, you are disconnecting. Your circuit breaker is going to disconnect. But once this pole operated, all three also will become 0. Then PA equal to PS means huge acceleration. Complete electric power output equal to 0. If I am going with a single pole circuit breaker, then PA is equal to PS minus fault is there only on this R phase. PY plus PB will be there. So PA2 I call, this is PA1 I call. PA2 is less than PA1, therefore acceleration will decrease. There is a possibility for the system to attain good stability, right? Therefore we are going to choose what? Single pole circuit breaker instead of three pole circuit breaker. Let's go for the next question. Yeah, during a disturbance on a synchronous machine, a rotor swings from A to B before finally settling down to a steady state point at C on the power angle curve. The speed of the machine during oscillation is synchronous at the point or points. This question is from equal area criteria. See, one must know how equal area criteria takes place. Yeah, this is the steam input I am giving. This is the steam input PS, right? And I'm going to draw the electric power output. Please have a look. This is the electric power output. This is 0, this is pi. See, my present operating angle is here. Present operating angle is here. I write it as I can say delta naught. This is point A. This is point A. Now here I can say here the speed is synchronous speed. Yeah, there is no fault, there is no change of anything, there is no fault, there is no change of anything. Yes, now that is at point A. Now all of a sudden, if steam input raised to this value, then finally my machine has to settle here. So I can say this is point C. Is saying that finally it is settling at C. But according to equal area criteria, what happens here is it will start moving. It will not stop here. It will go up to here somewhere B. So it is oscillating from point A to point B. At A, starting it is synchronous speed. It reaches to C. At C, though my powers are equal, but speed is more. Therefore, it goes up to here. And here again, it is going to attain synchronous speed. But power is negative. That's why again it swings back. It swings back like this. Right? So at points A and C, I can say like, yeah, what is saying? The speed of the machine during the oscillation is synchronous at points. Definitely at point A, it is a synchronous speed. Once a fault occurs, yes, its speed rises. Not fault occurs, steam input suddenly rises. If steam input suddenly rises, he did not given what is the case. PA is equal to PS minus PE. If PE increases, obviously PI will increase. Then the rotor starts accelerating. It starts accelerated. It reached up to here. At B, yeah, at B it is not. At B it is synchronous speed only. At B it is synchronous speed. Yeah, why? Because here at C I can say that it is the maximum speed, omega m I call maximum speed. Why? Up to C, PI is positive, acceleration power is positive. Up to C, acceleration power is positive. If acceleration power is positive, rotor keep on accelerating. Means here synchronous speed is there at point A. Then it rises up to maximum speed omega m or nm I call, or omega m I call, omega m. But why it is not stopping at C? At C, PI is equal to 0, but your rotor is under acceleration. then definitely angle further will increase. If angle is further increasing, observe it, good question it is. If angle is further increasing, the rotor is under deceleration, but speed is more, rotor speed is more. Till its speed is going to become equal to synchronous speed, it oscillates up to here. Now here the speed became equal to synchronous speed, but acceleration power is negative, therefore again it swings back. Finally it is going to settle at this point with a speed of synchronous speed. Now look at the options. The speed of the machine during the oscillation is synchronous at the points, I can say A and B. A and B. Finally at steady state, that will be at this is also at here also it will be at I can say ns, but he is asking during oscillation. He is asking during oscillations. The option is A and B. A and B. See, at A synchronous speed, B also synchronous speed, but at steady state C also at synchronous speed. Do not get confused. Okay, so C will be also at synchronous speed at steady state, but that is at steady state. But he is asking during oscillation, right? Let's go to the next question. Use of high-speed circuit breakers. Yeah, if high-speed circuit breaker you are using, stability of the system will increase. Yeah, if the protection system equipment is fast, right? Then if it is going to operate below critical clearing time, you know what is critical clearing time? It is the time just before which the circuit breaker has to open its contacts and the faulty section must be removed from the healthy section. Otherwise, if the time crosses that critical clearing time, then even though circuit breaker clears the fault, system will go into unstable mode. System will go into unstable mode. Okay, yeah. Reduces the short circuit current. No. Improves system stability. Yes, it increases. It improves system stability. Let's go to the next question. A 100 MVA 11 kV 3-phase 50 Hz 8-pole synchronous generator has inertia constant H 4 megajoule per MVA. The kinetic energy stored, the energy stored in the rotor body will be, yeah, it is simply 400 megajoules. That's all. Why I taken the same question 2 times? This topic is having that, I can say, that importance in the competitive examinations of Telangana state. Definitely one question from this area in power systems, in GENCO or TRANSCO or AE or AW, whatever it is. Okay, yeah. Let's go to the formula. You know, kinetic energy is equal to G into H, where H is the inertia constant, G is the rating of the machine, right? Next question. The Gauss-Seidel load flow method has the following disadvantages. Tick the incorrect statement. Yeah, it is unreliable convergence. That is a major disadvantage. Gauss-Seidel method is not giving the guarantee of the convergence, whereas Jacobian method, yes, means not Jacobian method, Newton-Raphson method is going to give the guarantee for the convergence. In fact, in Newton-Raphson method, we are going to use the Jacobian matrix, right? Let's go to the next one. Out of the following plant categories, the base load power plant are nuclear, run-off river, pump storage, diesel. So diesel will be never. Whenever it is urgent, then only we go for diesel, right? Pump storage is also because we have to put some cost. We have to pump the water to the up, then we have to get it. See, you are using electrical energy for lifting the water from down to up. Again, you are using the same for generating power. Unless it's an emergency, that kind of work we won't do. Now, nuclear can be used, runoff can be used. Therefore, 1 and 2 can be used as base load plants, right? Next question. The sudden change of pressure in penstock pipes due to sudden reduction of load is avoided using surge tank. Yeah. See, if surge tank is not there, water hammer effect will takes place, due to which I can say the pipes can burst. Pipes can burst suddenly if load is decreased, but water is coming with good flow. Water is coming with good flow, but that much water cannot hit I can say the turbine vanes. It means you have to stop the water. Suddenly if you stop the water, then definitely it will damage. Therefore there is a tank called surge tank. This entire excess amount of water we can't control suddenly. Excess amount of water can be diverted to a tank called surge tank, right? Next question. Which of the following turbines will be used for the heads from 500 to it is 500 and above? Okay, 500 above I can say. See, this one Kaplan is up to 15 meters. Up to 15 meters. This fixed vane propeller is from 15 meters to 70 meters. Greater than from 500 meters. Okay, forget about the 200. That is a typo. Francis is from 70 to 500 meters. Pelton wheel for greater than or equal to 500 meters. Pelton wheel is used. Yeah, this is not 50, this is 500 meters. Okay, that is direct question. Let's go to the next question. Which of the following heat exchangers is used to raise the temperature of steam from normal to supersaturation level? Superheater. There is an equipment called superheater that is used to increase the temperature, to raise the temperature of steam from normal to supersaturation level. Let's go to the next question. Which of the following treatments for water is used to remove non-carbonated hardness? Non-carbonate hardness, that is a soda treatment is used. I told you generation is very important. Spend good amount of time. Okay, all these are theory bits. There is no much logical explanation behind those statements. So I recommend always you to read those concepts. Yeah, let's go to the next. The hoppers in electrostatic precipitator are generally in dash shape, pyramidal shape. Those electrostatic precipitators will be in the shape of a pyramid, right? Let's go to the next question. The purpose of cooling tower is to, yes, the purpose of cooling tower is to cool the steam in the condenser. Yeah, the purpose of cooling tower is to cool the steam in the condenser, right? Yeah, let's go to the next question. The following is used to reduce the speed of the neutrons in a nuclear reactor. It is moderator. Moderator is used to control the speed of the neutrons in nuclear reactor. Yeah, so these are the 20 questions for this video. See, I am going to discuss in the upcoming videos good topics like load flows. See, people are having a lot of confusion in load flow studies. That is, I can say people don't know what data is given. Okay, people will forget what kind of convergence characteristics each method is going to have. We have Gauss method, Gauss-Seidel method, Newton-Raphson method, decoupled load flow method, and fast decoupled load flow method. We have 5 methods. Which method is more advantageous in what way? So I will be giving one very good table with explanation. Okay, keep following our channel and join your hands with YourPedia to accelerate your preparation. Thank you.